We're going to be following instructions which are given in this page, installing MOM6 in a virtual machine running Ubuntu, which you can find under the Pages tab on the right column of the MOM6 examples wiki. First thing you'll need to do is install Oracle's VirtualBox Manager from this link at the top there. Then once you've done that, you can run that manager, and in there we're going to click New, and we're going to create a Linux virtual machine, and if you give it a name starting with Ubuntu, it will automatically fill in the rest of the page for you. MOM6 demo. So it's selected Linux for me, and I'm going to do a 64-bit. I'm going to give it about 4 gigabytes of memory, just so it can actually do some stuff. And you do want to create a virtual hard disk now, and then we'll click Create. For the file size, I like to give it about 8 gigabytes plus virtual memory, so I'm going to make it around 12ish. Select VDI for the disk type and dynamic, so that it doesn't create a massive file for you now. And then click Create. And then one last thing is, if you just want to check the settings in there, you can browse through the settings at your leisure. But what I'm going to do here is just give myself a few more processors. I have an 8-processor machine, so I'm going to give half of it to my virtual machine. Now, one thing you'll need to do before you start launch the machine is you'll need to install or download an ISO image from your favorite Linux distribution. So I've downloaded from the Ubuntu's download site here. It's about 1.5 gigabytes for the full installation disk. You can do a network install, but I decided to make it all go quicker now for me if I haven't pre-downloaded it. So now I'm going to do launch by clicking Start. And you're going to be given a pop-up. It's asking you where is the installation disk, and I've got that there in my download folder. I click Start, and Ubuntu is going to fire up. Okay, that was it. Now I'm going to select English, install Ubuntu. Download updates while installing, yes. Continue. Erase disk install Ubuntu, install now. Continue. This is asking about the partition table. It's a virtual disk, it doesn't matter. I'm not living in New York. English. Now this has happened to me before, that the system doesn't find the windows are too wide for the screen, but let's ignore that. So let's go and I need to choose a password. And tab. Okay, and now it wants me to restart. Okay, there it is. We'll enter my password. Okay, so now we have a few extra instructions to do. So let me just pull us back to the instructions over here. So we've done the install, and after we've done the install, we have to do this. Where is it now? Here it is. We have to do sudo apt-get install dkms and then add the virtual Linux, VBox Linux editions. So sudo apt-get install. Let's open a terminal. sudo apt get install dkms. There we go. Okay, and then we're going to go to CD. We're going to install the devices. We're going to insert guest edition CD-ROM, media. There we are. We change location, and then here we're going to be running VBox Linux editions, and we have to do that with a sudo sh // Okay. And what this does is just to make sure that the virtual machine can talk to the host machine and you can do cut and paste and that sort of thing. Okay, sudo reboot. Okay, and we're back. So now the next step is to install the software needed to be able to actually build FMS software. And so there's several things we'll be missing from here. So we need to install some packages, and they're listed at the bottom of that page we were looking at earlier. This list here: git, shell, pkg config, and fortran, etc., etc. So we're just going to install those. So sudo get install git tcsh pkg config password yes. Okay, and then we also need to do the same for gfortran. And then we also need to do the same for netcdf. So we need the binaries, and we also need libnetcdf dev, which has the header files, which will be included by FMS. And then we also need the same for OpenMP. OpenMP bin and lib openmpi dev. Okay, now finally, at the bottom of the page, recently they've managed to split out some of the files so they're not provided by the package libnetcdf dev. There's now a new set of packages called libnetcdf-f, so we need to install those. So let's do that next. So cdf-f dev. Okay, right. So now we have all the software. I think we have all the software needed to build the model. Okay, so next we're going to actually clone all of the repositories. So we can use the command git clone, and we're going to do a recursive clone so we get everything that we need. And then we're going to paste the URL, which is no-dftl MOM6. Let me just make this wider so you can see it. And that's going to create a file folder, MOM6 examples. I'm going to put this in, actually rename the folder to demo. So it's cloning into demo. Okay, so now if we go into demo, you'll see the top of MOM6 examples. And if we go into source MOM6, you'll see the MOM6 source code, etc. So before we start compiling, there was just one thing we need to do, which was listed in the instructions for installing the FMS software here, And that is in the same way that we had to do this extra install of this package netcdff, we have to add -lnetcdff to the libs variable in the template that we're going to use. So let me just show you where that's going to be. So vi and then source mkmf templates, and we're going to use the Linux GNU template. And let's look for libs. There it is. We're simply going to add -l netcdff. So that's an extra that's the Fortran library. Okay. So we're now ready to start compiling, and we'll do that by going to the wiki again and going to the sidebar, clicking compile. And the instructions are here set up for the Intel compiler. So we have to do a bit of editing on these commands because we're going to use GNU Fortran. So first thing I'm going to do is make a directory to actually build the FMS libraries in. And we'll rename that to GNU instead of Intel. So you don't have to build everything here, we just like to give ourselves some structure. I'm going to go into build GNU shared repro. That's an empty directory. The next thing we're going to do is we're going to run the mkmf list paths tool, and we're going to give it the relative path to FMS, the source code. Okay, so what that has done now is populated this file, path names with all these files. And now we're going to run another mkmf tool, mkf itself, and we're going to specify the Linux GNU template that we edited a moment ago. And then we're going to tell it to build libfms and use these compiler options. I'm not sure if we actually need them, and then use that path names file that we just generated. And that has just made a makefile. And finally, we can now type make netcdf equals 3 repro equals 1. That tells us to use netcdf3 in repro mode. And then the other thing we need to do is specify the compiler. So fc is equal to mpi77 and cc equals mpicc. And our target is libfms.a, and we'll do this in parallel. Okay, so that's built the libfms code. I'll just show that to you. There it is. So now we're going to go back up, and we're in the GNU directory. We're going to make a new set of folders, ocean only, repro. And now we're going to run the list paths command again, and that is just there. And this time we're going to provide the current directory as a possible supply of source in case you want to put some source files in here. That's the dot. And then this is the relative path to the source code for MOM6. And we're going to be linking a dynamic executable. So we're pulling dynamic directory out of config source, and we're building using the solo driver as the driver out of config source. And then all of the source code under SRC is being used. Okay, that's made this path names file again, which is now populated with all this MOM6 source code. And then we're going to run the mkmf tool again, and this time the target there is MOM6, and we have to change the template again to point to the Linux GNU template that we are using, and that's that, and that's going to make a makefile. And now you can use almost the same command we used for the make before, except this time we have to change the target to MOM6, and we have to add a link step. LD is going to be MPI77 for linking, and there we go. Okay, done. So now we have an executable, which is called MOM6, and we're going to now go up and just demonstrate that it works. It's going to go all the way back up to the top of the MOM6 example directory, which I call demo, and we're going to go into Ocean only and double jar, our favorite test, and then we're going to use npi run. We'll use, let's start with one processor, and we're going to take the relative, find the relative path up to build GNU Ocean only through MOM6, and let's watch the model run. So you'll see it's got a decomposition. It's one processor, 44 by 40 points, not very big. It's a simple 10-day test. You'll get this error here when you haven't created a restart directory. Let me do that now. I always forget. Let's do that one more time. There we are. 10-day test. Took just about 9 seconds on my little virtual machine. And now I'm going to run it again. This time I'm going to use, let's use 2 processors, and it should go twice as fast. There it is, just over 5 seconds. And now, of course, this isn't perfectly scaling in a virtual machine, so when I go to the next number of doubling, it won't be that much faster, but it is a little bit faster. There we are, 4 seconds. Okay, so we now have a working version of MOM6 in a virtual machine.